Hello, welcome back to Algebra. The title of this lesson is Rational Root Theorem. This is part 2, or you could say finding rational roots of polynomials. So we've introduced the concept of the rational root theorem in the last lesson. We're going to be doing exactly the same method here as we have done in the last lesson, but both of these problems and also the problems in the next lesson are just a little more complex. It's hard to describe without getting into it. The reason they're more complex is because they're higher order, like a third or a fourth order of polynomial, and sometimes things don't factor so nice, so we have to use the quadratic formula or other little techniques to get down to the answer. But in all of these problems, all we want to do is find the root, so we set the polynomial equal to 0. So this first problem looks very simple, and actually this problem isn't too bad. It's the second problem here that's going to be a little bit more involved. So if we have 2x to the third power plus 3x minus 5. That's our polynomial, and we want to find out what the roots are. So we want to figure out what the values of x are that make this polynomial equal to 0. So we know that there's going to be 3 of them. There's going to be 3 of these roots. Some of them could be complex. If we do have any complex roots, they have to come in pairs, right? So we may have all real roots here, or we might have 2 complex roots, the conjugates, and then 1 real root for a total of 3. We don't really know ahead of time. So let's apply the rational root theorem and see if we can figure out what at least one of these roots is, and then we can find the other 2. So we take a look at the first number here, the coefficient of the highest term, and we try to figure out what the factors are. We know that plus or minus 1 is a factor of 2, and we know that plus or minus 2 is also a factor of 2. We've talked about factors in the last lesson. And then we look at the negative 5 here. Plus or minus 1 is a factor of pretty much everything, and then plus or minus 5 here. There are no other numbers that can be multiplied by something to give you 5. There are no other numbers that can be multiplied by something to give you 2 here. So from this list of information, we can write down the possible roots, the possible rational roots. So this means possible. This means rational roots. I have a little shorthand, possible rational roots. And they can be the following things. We can have plus or minus 1 over 1. We can have plus or minus 1 over 2. We can have plus or minus 5 over 1. And we can have plus or minus 5 over 2. That pretty much covers it. This over this, this over this, this over this, this over this. There are no other combinations of these numbers divided by those numbers. All right, so once you make your initial list, then you go ahead and try to simplify it and eliminate any duplicates. So we're going to simplify this list. Plus or minus 1 over 1 is, as you know, plus or minus 1. This is plus or minus 1/2. This is plus or minus 5. And this is plus or minus 5/2. So one way that you could do this, of course, is you could plug every one of these in. You have 4 times 2 because of each sign, so you have 8 possibilities. But especially with the fractions going in, it's going to be cumbersome to cube them and all the fraction arithmetic you have to deal with. So you could do that, but what you might end up finding is that none of them are roots at all. Or you might find that only one of them is a root. Or you might find, if you might be lucky and find that all 3 of them are roots. You don't really know ahead of time. So what we want to do is first take a look at the simplest thing to plug in. The number 1, plus or minus 1, is always going to be the simplest thing. So we're going to try this polynomial evaluated at 1. And that's going to be 2 times 1 to the third power plus 3 times 1 minus 5. Right? And so what you're going to have here is you're going to have, this is 1 times 1 times 1 times 2, so you have 2 plus 3 minus 5, and so what you'll have is 5 minus 5, which is 0, right? So because you have figured out that when you plug in the value of 1, you actually get a value of 0, what we have figured out here is, luckily enough, let's do it over here. X is equal to 1 is a root. All right, so we always want to try x is equal to 1. We got lucky this time, and we figured out that it is a root. But generally, we always want to try at least the next easiest thing as well. We might come up empty, but we might get lucky. So let's go ahead and try negative 1 to go into this thing. So let's try this polynomial evaluated at negative 1. And that'll be 2 times negative 1 to the third power plus 3 times negative 1 minus the 5. Now, the difference here is that we're going to have 2 times, when you cube the negative 1, it actually comes back to be a negative 1 as an answer. This will be minus 3 minus 5. And so what you have here is negative 2 minus 3 minus 5. So this is negative 5, and then minus 5 again is negative 10. So when